Okay, we're recording apparently. Let's go ahead and get started. So I wanted to remind you of a few things. We had our first lab sessions yesterday for the CSE 190 labs. If you weren't able to do that yesterday and you're interested, there's still time to sign up. Some of the lab sections require an entry code, but in every time slot, there is a lab session that has openings. So you can find a lab that has openings if you try one of the other labs. And so you can miss 2 of the 9 labs. So if you missed yesterday, then you can still sign up for the lab and still have the option of missing 1 more and still be able to get full credit for the lab. So if you're interested and didn't do it yet, I'd go ahead and sign up. Sections happen again tomorrow. As I keep mentioning, we have the Zoom links that has all of the various links, including the section and the lab links for our Zoom chat. Another thing that's on that Zoom links page is the link to use it for our engagement activities. So the engagement TAs have organized their first session. They're going to have a town hall, just kind of have people talk about what they're experiencing, what it's like so far, to be dealing with the remote learning and everything. So if you're interested in that, 5 to 6 on Thursday. And as I said, the link to it is under the Zoom links page. So that's our first engagement activity. I believe you got an email about it as well through the announce list. Okay, let's take a look at question of the day. So we're still getting a nice response to question of the day, and of course the answer is over, but I guess we have 15% renegades in the class who think that under is the right answer. I wanted to mention something. I could sound kind of preachy or something, but the problem is actually I'm talking to the wrong people. What I wanted to mention is that I've noticed that there are a lot of people who are not watching the lectures, and I think that's a big problem. The thing is, those of you who are watching this lecture, you're not the ones that I want to talk to. So I did want to mention that I think it's very important to attend lecture. Sometimes people ask me, how can we deal with the fact that there's a lot of people in this class who have prior programming experience? Believe me, that's not what predicts success in this class. There are a lot of people, it's helpful, to have learned something before, but that tends to make you sometimes, a little lazy about things. You don't necessarily you watch the lectures, you don't necessarily participate in section and so forth. So I've mentioned it before, the course is oriented towards novices. And in particular, the course is oriented towards people who have the discipline to do the things that we recommend that you do. And watching lecture is super important. Woody Allen made the joke that 80% of success is just showing up. There is a lot of, I think, important information that I give. So maybe what I'll say is, for all of you who are watching, I'm trying to give you encouragement to keep going. I think that this quarter in particular is going to be tough for all of us. It's going to be really hard to get the help you need to learn what you need to learn. So it's very important to keep watching the lectures. It's good that you're watching this. Keep doing it. Well, we're going to finish up the Chapter 2 material today. And I have posted, I mentioned here on the main page, that I have posted homework 2, so that you'll find that under the homework tab. So there's the specification for the homework, sample outputs, and so forth. You're going to be writing a program that produces a rocket ship as output. And the hard part of it is that it's got to be a rocket ship that scales. We'll see that. And what I'm going to do in today's lecture is something similar to what I did Wednesday of last week. I'm going to do an example with you. So I'm going to do a problem that's like what you're going to do in the homework. And so it lets me talk about all the different things that you're going to do. And my guess is that if you don't watch today's lecture, if you kind of don't have this, what I'm going to show you today, you would find this a really hard program. There's a lot of details to get right. And I thought I'd remind you of a quote that I include in the book from a fellow named Brian Kernighan, that controlling complexity is the essence of computer programming. Brian's considered a bit of a programming guru. He's the one who came up with the Hello World convention. So anyway, the idea here, I think, is a really important idea, that that the computer programs we create have a lot of detail to them, a whole lot of complexity, and it's very easy to get overwhelmed by all of that complexity. That's one of the reasons I think that intro programming classes often have a high failure rate or a high dropout rate, is that people just get frustrated. They can't deal with all of that. So a lot of what we're going to be talking about in today's lecture and in all of these things going forward is trying to help you to understand how to deal with that complexity, how to manage all of that detail in a program like this. All right, well, let me show you. I have updated the output comparison tool so that it has some extra things, like here's the rocket ship that you're going to be drawing, so you can see that. But I wanted to take a look at this output that Marty Stepp, my co-author, describes as a mirror, a bit of mirror. So we're going to write a program that produces this as output, so it's similar to what you're going to do in the rocket ship program. And we're going to do it in such a way, we're not going to just do printlns, println, the way we did in chapter 1, because then if we wanted to change it to be a mirror that had a size of 3, it doesn't shrink, it's not going to scale. So we want to do it in a way that's going to be able to scale. So this is kind of what we're going to do initially. Now, one of the bits of advice that I give in the homework write-up is that you should pick a specific size like this and solve this problem. So don't worry about the scaling part initially. Do that later. Get it to work at a specific size first. So we're going to work on getting it to work for size 4. That's kind of the way we're going to do this. So I've set up JGrasp. I've got an empty main for us to work with here. And I made a copy of that output. So I have a little text window here where I can talk about this. Well, so what's the first thing to do? You want to think about the lines of output here and kind of group them into things that are related. Like clearly this solid line that's at the top is very different than the lines that come after it. And it's repeated, actually. There's a bit of redundancy here that the solid line appears at the bottom as well. And then we've got a line of output that looks like this, and another one, and another one, and another one. And I guess what I would say is you could kind of imagine some kind of a loop that was going in one direction and then suddenly went in another direction. But that's tricky, to try to get that to work right. So from my point of view, the way I think of it is that there's 4 lines here that are sort of related to each other in that the figure has a consistent pattern that's going on here. And then there's another 4 lines that are going in the other direction, where the pattern is going in the other direction. So that's how I kind of want to divide this up. So in terms of overall structure, what I'd say is that there's a solid line, and then there's kind of a top half of this figure, a bottom half, and the solid line again. So what I'm going to do in my main is I'm going to say that I want to draw a line, then I want to draw a top half of the figure, I want to draw a bottom half of the figure, and I want to draw a line again. Now, it's going to take us a while to write all these different methods. There's an idea in programming that's called stub programming, that the idea is that you can kind of write little placeholders for these things for now. So let me have a public static void drawLine method, and for now, I'll just have it be an empty method. Public static void draw top half, and I'll just have it be an empty method for now, and public static void draw bottom half, and again, I'll have that be empty for now. So I've got kind of 3 stubs is the way we describe that, placeholders for what we're going to eventually fill in. But interesting thing about a stub program is that I can go ahead and hit compile. Now what did I do? Draw a line here. Oh, well, I did that on purpose to see if you guys were awake. You probably noticed I misspelled that, and that should have been a lowercase d. Someone asked me a question about this in email. Let me just kind of remind you of something. You always want to pay attention to that little up arrow character there. Where is it pointing? And then what does it say? It says that method drawLine, it cannot find the symbol. You got to pay very close attention, see whether you've misspelled something. In that case, I had the capital D instead of a lowercase d. So I wasn't really trying to do that on purpose, but it's not so bad that we got an error. So I can hit compile, and I could go ahead and run. I mean, it doesn't do anything. It's an empty program, but there's no reason that you can't go ahead and execute the program. I mean, maybe give you a little sense of success. I've made some progress. I've got, I haven't really done anything concrete, but so what? We've kind of made a little bit of progress. Well, actually, that lets me mention an idea that is an important idea, that part of this managing of the complexity involves writing the program in stages. So don't try to write the entire thing all at once. Do a little bit of code, put that in your program, compile it, run it, test it, make sure it works, then add a little more, add a little more, add a little more. Developing it in stages is really, really important. We talk about the idea of a development strategy, which would be kind of what are the stages you have in mind? What are the steps you're going to go through? And we'll often give you suggestions about a development strategy. You can talk to your TA, or you could talk to other students about the development strategy, not the details of the code itself, but if it's just the strategy of what are the different steps involved, that's something that is not considered misconduct to be discussing with other people, the development strategy. So if you do that, that would be helpful. This style of programming where you add a little more, add a little more, add a little more is sometimes called stepwise refinement, sometimes called iterative enhancement. It's the way programmers work. That's the way to succeed, is to do things a little bit at a time rather than trying to do the whole thing all at once. All right, so let's come over here. So of these various things, I think the solid line is kind of the easier thing to do first. So if we're going to pick off something to get done, let's get that done. One of the ideas mentioned in Chapter 2 is the idea of using what we call pseudocode. Pseudocode. The idea is to write something that's not really code, but it's kind of like code. You write things in English, and you don't, require that it be correct Java syntax. Like if I wanted to describe what I'm doing here, print a line of dashes. Print a line. I'll say print a line. That's what I want to do. That's an English description. Not a very helpful English description, but it's an English description of what I want to do. And the idea with pseudocode is that you want to refine this, get a little closer, a little closer, a little closer. Okay, so what would we do in printing a line like this? You know that in Java, the output goes from left to right. That you have to begin at the left-hand side of the line. And the very first thing you see here is hashtag character, number sign character, whichever you want to call it. So we know that the very first thing to do is to print that hashtag character. That's going to be the first thing that we want to do. Then what? Then we print a bunch of equal signs. So how about if I say print some equal signs, and then we're going to print another hashtag. And remember I mentioned in Monday's lecture that there's this system.out.print versus system.out.println. So we're going to do a bunch of print commands with all of this, and then one println to kind of complete, I don't have to put the parens just yet, one println that will complete the line of output at the very end. So this is the pattern we want to follow. Print, and then one println that's going to complete the line of output. So that's a better pseudocode description than just print a line. It's more detailed. It's a little closer to being code. Still not code, but it's getting there. So this is kind of a helpful exercise to go through, is to be able to write it in English and refine it a little bit. Well, how could we refine some more? How about some? Some equal signs. Well, how many? Let's try to figure it out. I tend to be old school, so I tend to use the cursor for things like this. So I would position up here in the line, and I'm going to hit my right arrow key. And I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I can kind of see how many times I have to hit the right arrow to get that. So that's kind of a nice way of counting. My co-author, Marty Stepp, wanted to make it even easier for people. So he decided that if you select all of those equal signs, it will tell you that you have 16 characters selected. So you can use the output comparison tool to count these different numbers of the various kinds of characters that we're going to have in here. So that's a nice option. So instead of just saying some equal signs, I'm going to say 16. We know, though, that we want to create mirrors that are going to be of different sizes. We want to scale the mirror so that it get, and as we scale it, that line is going to be shorter or longer. So it's not always going to be 16 equal signs that we're going to want to print. So what that means is that this is something where we're going to want to use a loop in order to be able to have the flexibility to change how many times we're going to do that. So if we want to refine a little bit further, how do we do something 16 times? Well, that's what for loops are for. So I could say something like for int I starting at 1, I less than or equal to 16, I plus plus. That's how you do something 16 times. That was our pattern from Monday, is that a for loop that starts at 1 and goes less than or equal to some n is going to do that thing, whatever's in the body of the loop, it's going to do that 16 times. And what do we want to do? We want to print an equal sign. So we want to print one equal sign 16 times. So that can kind of replace this description here. You see how I'm kind of, slowly but surely getting it a little bit closer to being Java. Okay, well, we can be a little bit more specific. We don't have to use this English word print. We can say system.out.print with a double quotation mark. So let me go ahead and select this right here, and then I can come down here, and we also know we're going to want to have a close quote, right paren, semicolon. Here we could do the same thing, and we know that we want to be printing an equal sign here, close quote, right paren, semicolon. Same thing here. You might have noticed that JGrasp is not color coding this. That's because I'm in a text window. So when I put it into a Java window, it'll color code it. But it's not doing it here because I'm using text, a text editor. And then we do the println. So now I've changed it into actual Java code for all of this. A print command, a for loop that does this, print, and a println. Let me mention one thing before we go on. So this would be a fine way to do it. It's not a bad approach, but most programmers wouldn't write it in this way. If you're going to do a print command followed by a println that completes the line of output, you can just combine that into the println command. So when you put some text in the parens for the println, the understanding is the first thing that it does it does the print part of it to put that text at the end of the line, and then it does the println part, which goes to the beginning of the new line. So we wouldn't tend to do those as two separate lines. Not a big deal if you did it for now, but it's something that programmers would tend to collapse into just a println. Well, I think I can copy this now. I think it's pretty good. I mean, we'll find out. Normally, if I have students in the room, they would tell me, it's like pre-compilers in the room, and they tell me, they notice mistakes that I made and that they'd let me know. But we'll find out soon enough. So now you notice the color coding is appearing because now we're in a Java window. I'm going to select these lines of code right here. And JGrasp has a really nice feature. See, the indentation is off here for these lines. So what I'm going to do is I'm going to hit the tab key, which indents at 1 level. And I'm going to hit the tab key again, which indents at 2 level. And that's the correct amount of indentation. You'll notice in the general style deductions for this week that we're now going to be grading on proper indentation. So starting with homework 2, we want you to be using proper indentation, and you could lose style points if you didn't do it right. So this being able to select lines and hit tab to move it over is nice. If you tabbed too far, you can hold down the shift key when you tab, and when you do a shift tab, it scooches it back. So, tab to move that way, shift tab to move back to where you were before. All right, well, let's see what happens when I compile this. It compiled, and if I try running it, I get a couple of lines of output. This may not seem like much, but I'm going to go ahead and copy it and come over here, and I'm going to paste them in. The two don't look all that similar, but let's go ahead and hit compare. And actually, this is good news. I mean, it's showing that the difference is the things that aren't the solid line. In fact, you can see that even more obviously when you add line numbers. You can see that it's lines 2 through 9 of the output that aren't correct, but lines 1 and 10 of the output match these lines 1 and 2. So we got that right, so that's good. We know we can kind of move on, at least in terms of the solid line. That part of it we have correct. Let me go ahead and remove those line numbers. Okay, well let's come back then to JGrasp. So I was in this little window here where we did the first part of the program. Again, this is the way that you should work on the rocket ship. You should identify the different kind of sections of the rocket ship, the different bits of line that are the same, like we did here, and you should work on just one section of the rocket ship output, just like we did here, just like the solid line. Do one part of it, get the code, write the code, enter the code in a Java program, compile it, run it, and see if it works. So verify part of it first. That's that iterative enhancement, that stepwise refinement, that kind of doing things in stages. So very important to do the kind of thing we did here, where you do part of it first. Okay, now we're ready to move on to this part. And this part's going to be harder. There's more to do here, more complicated things that are going on here. One of the things to notice about this output is that it's a multi-line. That there's a total of 1, 2, 3, 4 lines that are here. So we know that we're going to want to have nested loops. So this is what we were working on at the end of Monday's lecture. So let me kind of say in pseudocode, for each of 4 lines, I'm going to want to do something inside of here. I'm going to want to be, doing various commands to produce the individual lines. And I've been saying, but it's worth repeating, you're going to do print, various print commands to do print, all on the current line, not going to a new line. And then we always finish that up with one println that goes to the beginning of the new line. So a bunch of print commands, and then one well-placed println there that completes the line of output. So, and I've mentioned a couple of times now this idea of chunking things in your head, being able to kind of group things and structure things. And so it's very important, even when we get to, we're going to end up with a pretty long bit of code here, but what programmers are going to do is they have the ability to kind of collapse that mentally and see, well, at the outermost level, I just have a loop that's producing 4 lines of output, and it's going 4 times. So to be able to think of it this way, to conceive of it in this way, is important for programmers, even when what's inside the loop starts becoming complicated. All right, well, let's be, this is our pseudocode that's not very specific. Let's be more specific. So you want to look at a line like this and try to come up with a general description. What's a description of what's on that line? And again, output is produced left to right. So the very first thing that's here is there's a vertical bar character, okay? That's that first bit of output here. Then you could say there's some spaces that come next. Well, here there's no spaces. So is that really kind of the general rule? I'm going to say print spaces, but for this one I'll just mention possibly 0. Maybe there's going to be 0 spaces to produce. But 0 is a number. It's a number of spaces. So it can, one of these things can be 0. But kind of the general description for the lines that works for all of them is going to have to incorporate the idea that we'll print some spaces. And then what comes after the spaces? There's a less than, greater than. So we're going to want to print a less than, greater than. And then here, what comes next is another less than, greater than. But on the other lines, there's dots in between. So if we want our general description that works for all 4 of the lines, we'd say we're going to print some dots. And then what comes after the dots? Another less than, greater than. So we'll say print less than, greater than. And then what comes after that is some more spaces. And what comes after that is a vertical bar character. So this is a pretty good description, of the details of this line, kind of, what are the different parts of output that are on this line. And I think you can see that what I did just now was a fairly mechanical style thing, where I just went from left to right. I just kind of wrote down what are the different pieces here, what are the different kinds of output that we're going to be producing, and I just put a little pseudocode description for it, for each one of those things. Okay, well, now, obviously we're going to need some loops for some of these things, and basically we're going to need the loops whenever I say something like spaces or dots. That's where we're going to need loops, because we want more than one of them. And even more importantly, like looking at the dots, there's different numbers of dots on different lines. So that's going to be something that's going to require a loop to have the flexibility to be able to do different numbers of dots on different lines. Let me point out that don't forget what you already know. For some reason, I see people do things like they'll turn this into a for loop that prints one vertical bar character. I mean, if you only want to print one of something, don't make a loop out of it. In fact, the general style guidelines mention that if you have a one-to-one loop, that's what it would be, a loop that starts at 1 and goes to 1. That would be a style deduction. So we want you to recognize when to use a for loop and when not to use a for loop. And if you're doing something once, don't use a for loop. So that's not where we want the for loop. We want the for loop here, to do print spaces. So how are we going to do print spaces? We're going to have some kind of a for loop. So we could say, oh, and actually, before I do that, let me do the outer loop. Let me be a little more specific about the outer one, because we're going to have this issue of outer loop and inner loop. So I can be a little more specific than each of 4 lines. I could say for int I equal 1, I less than or equal to 4, I plus plus. So that's what we did on Monday. I is fine. I'm going to show you an example here, though, where I use a different name. I think it's nice to call it line. It's just a better variable name for what we're going to do. So for line starting at 1, line less than or equal to 4, line plus plus. You can use whatever name you want, so I'm using line. And similarly here for spaces, to have a for loop for spaces, I could use I could use j. I'm going to say for int spaces starting at 1, spaces less than or equal to, well, we don't know how many spaces. So I'm going to put question mark, spaces plus plus, and inside of here, we're going to want to print 1 space. So that's kind of how we're going to replace this description of printing spaces. We want a for loop. I'm going to use a variable called spaces. Now, obviously, this isn't going to compile, right? The question mark, we got to fill that in. We'll have to figure that out. But we'll get there later. We'll figure that out later. Right now, I'm still kind of dealing at the pseudocode level. Similarly here, I could have for int dots starting at 1, dots less than or equal to something, dots plus plus, print a dot. And then when we had the print, and then we don't need this print dots because that replaces that. And print spaces is going to be replaced with int spaces equal 1, spaces less than or equal to something, spaces plus plus. And then we would print a space inside of here. So, and that kind of replaces this. So again, it's a little bit closer than what we had before. Let me scooch it down so we can kind of see the whole thing. So it's getting closer, slowly but surely, to something that looks like actual Java. How about if we fix what we did before? Remember we did the system.out.print with an open paren and a quote. Let me make a copy of that because we're going to do that a bunch of times. And we're going to turn this into printing a vertical bar character. We're going to turn this into printing a space. And the way you do that, you don't put quote, quote with nothing in between. You put quote, space, unquote. So there's one space there in between those quotes. We would do system.out.print here to print out the less than, greater than. We do a system.out.print here, and the way we would in dot, now we want an actual dot, and we would print out that less than, greater than here. So I'm just kind of turning my English description into a Java description. Again, to print a space, you have quote, space, unquote. And then this system.out.print would be printing the vertical bar character and we would turn the println into system.out.println. Okay, we're getting really close, in terms of code. There's an awful lot of code here now. One of the things, obviously, we have to fill in is the question mark, question mark, question mark. How many spaces, how many dots, how many spaces? That's going to be a hard part. We'll do that in a second. Before I do that, you could kind of take a look at this, and can you see anything where you would suggest a slight change? I'd normally ask. Normally would get a nice volunteer who would say, well, again, I've got a print followed by a println, and what most programmers would do is combine that into a simple println. So we'll print a vertical bar character. We'll have that inside of the println. So that's a slight simplification, but that's what programmers would tend to do, is to put those two steps together, the printing of the vertical bar at the end, and then go to a new line. All right, so what we have left to do is to figure out the question marks, the numbers. But again, let me point out, this is a fairly mechanical thing that we're doing here. This doesn't require a whole lot of knowledge or insight or practice. We're doing something pretty mechanical in terms of trying to turn these pseudocode descriptions into something that's very much like code. And we're about to do the same thing here. So, okay, what's going on? Let me mention that what we're about to do, what I'm about to describe to you, is something that you would have learned about in a class with that name. I'm not going to say the name because some people have bad memories of that class. And I guess the good news is it doesn't matter whether you remember things from that class or not. We'll teach you what you need to know here. So we have a variable called line, which is taking on the values 1, 2, 3, and 4, right? That's what this outer for loop is doing, is a variable called line that takes on the values 1, 2, 3, 4. We want to draw a certain number of spaces, a certain number of dots, and a certain number of spaces. So we need to figure this out. And what we recommend is that you use a table. So kind of call it the table technique. That's going to help you figure this out. So make a table. So line 1, 2, 3, 4. Figure out how many spaces are here. You could use the output comparison tool, or I could do the 1, 2, 3, 4, 5, 6 spaces here, 1, 2, 3, 4 spaces here, 1, 2 spaces here. So that was on the first line, there were 6 spaces. On this line, there were 4. On this line, there were not 32, but 2. On this line, there were 0. So count how many of each there are, put it in the table, and then we'll come over here. How many dots are there? Well, there aren't any dots on that first line. The second line, there's 1, 2, 3, 4 of them. And if you count here, you'd find that there's 8 of them. So I'm not going to do the actual counting because you could do that. But, you would do this, and you would find that there's 12 dots on that final line. So count, how many of each of these things there are. Now we could do spaces and fill this in, count how many spaces are here. But again, I normally ask, does anybody notice anything? And what people will notice is however many spaces there are on the left-hand side of this, it's the same number of spaces on the right-hand side. So we don't need to compute this twice. We don't need to have kind of an extra column for the spaces. Because whatever we do on the left-hand side, we're going to want to do on the right-hand side. There's a symmetry to this figure. So we don't have to do that. All right, well, so how do you do this? We're going to do something that's equivalent to slope-intercept, if you remember those concepts of slope and intercept. We call it choosing a multiplier and choosing a constant. So there's 2 steps to do. You do the multiplier first, you do the constant second. And this is stuff that we have in the section problems for tomorrow. You get to practice this some more. The table technique, it really simplifies what we're doing here. So here's the idea. Notice how line is going up by 1 every time, 1, 2, 3, 4. Well, what's happening with spaces? 6, 4, 2, 0. It's going down by 2. So how do you turn something that's going up by 1 into something that goes down by 2? You multiply it by -2. That's the only way to get something going up by 1 to go down by 2. So -2 times line is the multiplier. I throw in a multiplier of -2 times line. That's the slope, if we were doing a line. And then we want to think about, well, now what constant do we have to add to this? Or what do we throw in? This is the intercept. What do we need to throw in to make it work? Well, when line is 1, this is going to give me a -2. And -2 is not what I wanted. I wanted 6. So what would I have to add to -2 to get a 6? The answer is 8. So if I add an 8 to -2, I get a 6. And you could try plugging in these others to make sure you've got it right. Well, when line is 2, this is -2 times 2, which is -4. -4 plus 8 is a 4. You know, when line is 3, -2 times 3 is -6 plus 8 is a 2. So you can kind of check for yourself, but it should work if you kind of picked a multiplier based on how these things are changing, and then you threw in a constant that made it work for the first, row of the table. It should work for all of them. But, you can double check, make sure. So a multiplier and a constant. That's the table technique. Let me come over here. So you'll notice that if you go from row to row to row here of the table, we go from 0 to 4 to 8 to 12. These numbers are going up by 4, plus 4, up by 4. So how do we take something that's going up by 1 and turn it into something that goes up by 4? We multiply by 4. So 4 times line will give us something that'll go up by 4 every time. So that's the multiplier. And then what constant do we want? Well, when line is 1, we want to get a 0. Here, when line is 1, we're going to get a 4. So what's the constant? We want to subtract 4. We throw in a -4, is basically our constant, adjusted down by 4. And again, you could plug in the different line numbers, and you'd find that's giving you the correct expression there. So this is kind of probably the most confusing part of what you're doing in the homework, is dealing with these tables and coming up with these expressions to be able to put those back into the code. Let me select this expression right here, and I'll make a copy of it. That was for spaces. So here, when we didn't know quite how many spaces to do, I'm going to even parenthesize this to make it really clear that that's computing a number. That's computing a number of spaces that we want. How many spaces do we want? And here, too, we have parenthesized that expression. You don't need the parens, so I'm just kind of putting them in there for emphasis. It would be fine without them. But that's kind of how many spaces we want. And how many dots did we want? This was the expression for the dots. So let me make a copy of that. And we can come here, and we can have that expression for the dots. So again, it was pretty mechanical to come up with this outline of the code to begin with. We needed to come up with 3 different places where we filled in an expression. The table technique helps you figure out what those expressions are, and you then plug those back into the code that we had here. So I wasn't intending to introduce any bugs there, but let's see what happens when I bring it back over. And we'll try putting it in the draw top half method. Now we see the purple color coding for Java. We didn't have it before. I have to select all those lines of code that I have, and I need to hit tab. I need to kind of scooch them over. So that was those lines of code here. There's the outer for loop that's doing the different lines, and then our inner lines of code for all the different bits of output. Let me compile it. It's a good sign that it compiled without an error. Let's try running it. And when we run it, we get this output right here. Looks pretty good, but we can go ahead and copy it, and I can come back over to the class web page and replace what I had here. I'll paste this in and ask it to compare this. And now it's showing that it's just the bottom half. So that's good. I mean, now we've got kind of the solid line and the top half of the figure matching. We just have to do the bottom half. I'm going to do this in a slightly strange order. I'll mention why towards the end, but I'm actually not going to do the bottom half just yet. I would recommend that for your program that you get all your different sections of the rocket ship working. So in your case, I think it's better to do all of these little subproblems, get one rocket ship output to work correctly. But in this case, I want to switch to something that in some sense is more important for me to talk about, which is the scaling part. So how do we make it so that we could make something that's size 3 versus something that's size 4? Well, so there's a lot of issues here. Let me also say that the strong advice in the assignment write-up in terms of a development strategy that you do the scaling part later. So get it to work once, for one size output, and then do this after the fact. So suppose you got it to work for one size output. You're going to have to, first of all, think about how do I express the scaling? Well, a lot of ways of thinking of what's going on here. What I would notice is that this half of the figure had the 4 lines in it. And when I go here to this other one, this smaller version of the mirror, there are 3 lines in the top half. So, you can already see I'm saying size 3 and size 4, that I've decided I'm going to describe these as being, in terms of the scaling. I'm going to think of it as a mirror of size 3, where the half of a figure has 3 lines, and a mirror of size 4, where the top half of the, that figure has 4 lines. So that's the way I'm going to think of my scaling. We're asking you to use something new here. So this is described at the end of chapter 2, is I'm going to throw in something that's known as a constant. Let me just put it there, public static final int size equals 4. So this is something that's not inside a method. This is outside of a method. So it's something that's at the class level. It's an extra element of the class. And that's why we have to kind of throw in the public static information. Having something that's declared to be of type int, that's like a variable declaration. The word final is a special keyword in Java, notice that it's purple, that says no one is allowed to change this. This isn't like a variable. This is like something that has a permanent value, never allowed to change. So that's why we call it a constant. The convention in Java is that when you introduce a constant, you should use all uppercase letters for its name. So that's why I put size in all uppercase. If I had multiple words, you're supposed to use the underscore. So like size of subfigure, I could do something like that. So all caps, throughout the name, but underscores then if you had more than one line. Size seems fine. We'll just call it size. Public static final int size is 4. So one of the things that's true is that kind of declaring this here as part of the class, it means that throughout the entire class, I can access this size. I can see that there's this thing called size, which is a 4. So we have to figure out what goes on when you're trying to move something from producing output like this to producing output like this. So this is the one that's of size 3. And basically, you're going to use the table technique again. So you're going to do something very similar to what we did before. So what did we do when we made the solid line? Well, we figured out that there were 16 equal signs, right? That's what we did here. Well, so let's think about what's going on here. I can come up here and say that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. So if I think about this, I'm going to make a table. Now my table entries are going to be based on size, not based on a line. So for a size of 3, there's kind of the question mark, the question of how many equal signs there were. There were 12 of them here. There were 16 of them here. So we just counted. We counted in the one case and found 16. Here I counted and found that there were 12. Well, so you could do the exact same thing that we did before. Look, size is going up by 1 here and going from 3 to 4. And as size goes up by 1, the number of equal signs goes up by 4. So that means we need a multiplier of 4. 4 times, in this case, size, because we're doing a table based on size, not a table based on line. So 4 times size would be the right thing to use. And then what multiplier do I need to throw in? Well, when size is 3, it gives me a 12, so it's kind of already the right thing. You could think of it as, the constant is plus 0, or it doesn't need a constant, however you want to think of it. But that's kind of, the table, again, is the way to be able to figure out these expressions to use. So I don't want to say 16 equal signs. I want to say 4 times size of them. By the way, the version that we had, I'm going to have a kind of a complete version of it that draws the size 4 figure, and I'm going to have that be called mirror 1, I think I call it, on the calendar. So you'll have a version that doesn't have the constant, and then you'll have the one we're working on here, which is the one that creates the one that uses the constant. So we had a 16 here. Instead of 16, we want 4 times size. So we put that expression in there to make the number of equal signs change. All right, well, how do we deal with this top half figure? What I'm going to do is I'm just going to solve it all over again. I'm going to make myself a little table, line 1, 2, 3, and I know that I wanted to know how many spaces there were, and I wanted to know how many dots we needed to have. Well, so let's do it here. Let's just figure out what it is for this version. The number of spaces on the first line is 1, 2, 3, 4, and then there's 2, and then there's 0. So this goes 4, 2, 0. How many dots? There are 0 dots on the first line. There are 4 dots on the second line. There are 8 dots on the next line. So I'll just solve it all over again. This is going down by 2 every time, while this goes up by 1. So I need minus 2 as a multiplier to make it go down by 2. Minus 2 times line. And that would give me a minus 2 when line is 1, but I want to get a 4. So I would add 6 to it in order to get the right expression. Dots is going up by 4 every time, so 4 times line. When line is 1, I want a 0. So I do a minus 4 as kind of the constant that I throw in. So that's just kind of resolving all over again, just like we did before. And then make a second table for size of 3, size of 4. We want to know kind of how many spaces did we need, how many dots did we need. So this was kind of the answers when size was 3. So I'll paste that. And over here, I had made tables that got me the answers. This is what I wanted to have when it was a size of 4. So I'll kind of come over here and put those in here. So now you just kind of do the same kind of trick, but with an expression. All right, both of those have minus 2 times line, so that didn't change. But this one is plus 6, and this one is plus 8. When size goes up by 1, this number is going up by 2. So I can do plus 2 times size, multiplier of 2 on the size, in order to get it to go up by 2 every time. And when size is 3, 2 times size gives me 6, which is what I wanted. So I don't have to worry about a constant. And notice here that the expression didn't change. So the dots expression is something that I don't have to actually change. It's just the spaces expression that I have to change. So let me go ahead and make a copy of that. And let me replace what I had in the parentheses here with the expression for spaces. That uses size. Let me do the same thing here and replace that, the expression that uses size. Not quite done, though. Remember, there was the outer loop that went 4 times, so I got to change that too so that it goes size times. So let me scooch this up and see if I compile and run. Looks like I'm getting the same output as before. I could kind of verify with the output comparison and make sure, but I'm pretty sure that's correct. We're down to just a couple of minutes. Let's see what happens when we shift our size to be 3. And it looks like we're getting a correct output. We could again verify if we made it 8, just to kind of see something really big. It seems to be working right. So the scaling seems to be working. All right, we got a little over a minute left. Let me just kind of mention a last idea before I end here. So we didn't do the draw bottom half. This is an unusual figure in that the lines that make up the top half are exactly the same as the lines that make up the bottom half, but in reverse order. That's not true of your homework. Your homework's more complicated. But here, we could really just produce the exact same lines of output in reverse order. So you'll see in what I'm going to post today that I made a copy of all of these lines that are in the method, and I just turned it into a loop that went down instead of a loop that went up. So I turned it into a backwards loop that does line minus minus instead of line plus plus, and then that gets me the other half of the output. On Friday's lecture, I'm going to talk a little bit about the issue of redundancy in this program. But we've done enough for today, so let me go ahead and end there.